So this will be the coverage. Let me just open the Adobe na para makita ninyo yung ano. It's not scary, no? Do you follow? Mostly concepts with a few problems, no? Ninth edition book. Do you follow? Ninth edition book ang ating basis, no? Do you follow? Can you see my ano na share ba? Tama ba pagka-share? Can you see my ano? My screen, everyone?
Yes, sir.
Yes, sir.
So, bali chapters 3 to 6. Konti lang sa 6, no? Konti lang sa 6. A very important topic which I can also discuss with you today. Okay? Basically, ito yung coverage. You can look at that here now. I've given the ano. Okay. March 14 to 18, no? Para you can take your time. Okay. Review questions 3.1 to 3.5. Review questions lang. Page 107. Let's go there. Page 107. Okay. So, madali lang concepts, no? What are the general categories of functions? Computer, it's there, no? In our slides. List and briefly define the possible states in an instruction execution. Okay, there are 6 states there. List and briefly define 2 approaches to dealing with multiple interrupts. Diba? Multiple interrupts. Okay. With short interrupts and long interrupts. No? So nesting of interrupts and then priority. Do you follow? No? So nandito na ito. No? That's 3.5. 3.4. What are the types of transfers in an interconnection in a bus structure support, no? So meron tayong load and store, okay? No? So merong load and store to memory, merong load and store to input output device. What is the benefit of using a multiple bus architecture compared to a single bus architecture? Anyone? Do you know this? Diba? Kailangan ng multiple bus architecture because sometimes devices, the speed of devices vary. No? Some devices are fast, some devices are small, are rather slow. No? So sometimes you have a slow bus and you have a fast bus. No? So you have an internal bus, you have an external bus. The internal bus is the fast bus, and then the external bus is the slow bus. No? Do you follow? And then page 109, problems. We have solved this already, no? Nasolve na natin ito. You just solve this again. Okay? In fact, that's one of your assignments. Any questions? No? And then in page 147, that's in chapter 4. Chapter 4, 147. Okay. Review questions 4.1 to 4.7. Concepts, no? These concepts. 147. Bakit wala sa 147? Ito, no? Okay. Okay. Ito. 4.1 to 4.7. Very important concepts because this course is about concepts, no? What are the difference among sequential access, direct memory access, and random access? Is there in our slide, no? The general relationship between access time, memory cost, and capacity. We had a problem on this. The principle of locality, no? You must be able to explain that, no? Kasi ginamit yun sa pag-explain ng the importance of cache. Okay? So the differences between direct mapping, associative mapping, and set associative mapping. Now you should be able to compute the fields, no? in a direct map cache, no? For example, what are the three different fields? Of course, you know that there's tag, cache block, and offset. Okay. For associative cache, a map main memory address is viewed as consisting of two fields. Okay, so dalawa lang, tag saka offset. Okay, the tag is also called as the block address, no? So, combine na doon. Okay. For a set associative map cache, a main memory address is viewed as consisting of three fields. So, three fields kasi nagdagdag yung set number. How do you compute the set number? The address mod number of sets. Okay? Any questions? Hanggang 4.8. Okay? Ano? 4.7. Oh, alam na natin yan, no? Wag na lang 4.8 and 4.9 hindi nakasali na. Any questions? And then for problem 4.8 in page 4.7, we have solved this. Consider or something like this. Consider a machine with a byte addressable memory. How is a 16-bit memory divided into tag line and no? Okay. 32 lines ang kanyang isang cache, no? I have a sample of this, a very broad example. In a 16-bit memory address, no? 2 to the 16 is 65536. Divided into tag, line, memory, and byte. Okay. So do you follow? So how many bits are tagged? How many bits is the line and offset? Okay. Offset is also called the byte. Line is the cache number, no? Cache line number. What would be the bytes? Saan papunta ito? No? In a direct map cache. Do you follow? Suppose that the bytes are stored. What are the addresses? No? Why is the tag also stored in the cache? We explain this. No? Do you follow? We have explained this. Okay. We have explained this fully, I believe. No? And then lesson 5, no? Chapter 5. So basically, chapters 2 to 6. Konti lang yung cover natin sa 6, no? Page 181. Okay. 179, 180, and 181. Okay. Review questions. What are the key properties of semiconductor memory? We know the difference between semiconductor, no? DDR, SDR, and DDR. Okay. So transistors. No? And then what are the key properties? Mas mabilis. It occupies larger space. No? What are the two interpretations of the term random access memory? No? It's there in the text. The difference between DRAM and SRAM. DRAM is made of capacitors, charged. No? SRAM made of transistors. What is the difference between DRAM and SRAM in terms of characteristics such as speed, size, and cost? We know that DRAM is smaller, SRAM is larger. Okay. DRAM is slower, SRAM is faster because DRAM has a feedback, no? Kailangan niyang every time you read, it has to recharge. And SRAM is costly, it is used for cache. DRAM is used for memory, okay? 5.6, what are the some applications of ROM? You know that, no? Like the CMOS ROM, the BIOS. No? What are the differences between EEPROM, EEPROM, and flash memory? Okay. Okay. Flash memory is made of solid state, no? Transistors. EEPROM is erasable, programmable PROM. What is EEPROM? Anyway, you find that out, no? Hanggang 5.7 lang, no? And then for lesson 6, I'd like you to review question 6.8 and 6.9 in page 219. Before we go to that, no, I have given a simple lesson, rather reference in our regular site. Now that lesson is about external memory, and external memory is about hard disks. Do you follow? So nowadays the popular hard disks are the SSD. So we know the difference between HDD and SSD. HDD are made of disks. SSD are made of solid state transistors, no? Like SRAM, no? So in the past, no, when hard disks or mechanical hard disks are very popular, there's a technology called RAID. I would like you to understand this. This is still useful in SSD, no? So RAIDs means redundant array of independent drives or redundant array of inexpensive disks. Do you follow? So is your PC RAID based? Usually, no, RAID 0 on first level, RAID, redundant array of independent disks or inexpensive drives, okay? So it's a redundant array, which means that it's a collection of drives. Now, if you only have one drive, you have RAID 0. There are different levels, no? RAID 0 is striping, RAID 1 is mirroring, RAID 5 is striping with parity, 6 is striping with double parity, RAID 10 is actually RAID 10, combining mirroring and striping. Ganito yung RAID 0. The concept of RAID 0 is like interleaving. If you have two disks, okay, you can subdivide the block by striping it across, no? For example, because hard disks load data from disks to memory in terms of blocks also from the principle of locality, that if data are contiguous, no, inside memory and inside hard disks. So you have block 1, block 2, block 3, block 4, block 5. Hindi siya sequential, no? So if it's sequential, there's no RAID at all. In sequential, in RAID 0, the two drives can operate at the same time. So this will have improved performance because they can read and write different addresses at the same time. Do you follow? Okay, it offers great performance because two things can be done at a time. It's not fault tolerant, which means that if one of the drives, the disadvantage is it's not fault tolerant. When one of the drives gets defective, you lose your data. Do you follow? RAID 1 is mirroring. Okay? So, you know how to mirror, no? Doon sa CMOS, set up mo lang. It's done on the CMOS setup, no? If you have a RAID CMOS, you can specify how your hard disks will behave in a RAID fashion, whether RAID 0 or RAID 1. No? Pag RAID 1, all the blocks are sequential, but they mirror each other, which means that if you have 1 gig hard disk and you have two 1 gig hard disks, eventually you will only have 1 gig. Why? Because they mirror each other. Block 1 is a mirror of block 1, block 2 is a mirror of block 2, block 3 is a mirror of block 3. No? I have tried this myself. No, some of them are hot pluggable disks, such that if you remove the mirror, the operation will go on as like normal. No, normal operations will go on, even if one of the disks will be destroyed. Do you follow? So this is the main advantage is it's fault tolerant, but it's slow. Okay, do you follow? This is used for large servers, no, accounting systems where fault tolerance is required. Okay, RAID 5 is striping. This is striping also, but with parity drives, with parity checks. Now, if you have 1, 2, 3, 4, and for every 8 blocks, no, for every 8 blocks, one block is a set of bytes. No, you will have a block for the parity bit used in Hamming code. 1, 2, 3, 4, 5, 6, 7, 7, 8. Okay? So, yung dalawang parity codes, you have discussed Hamming codes in data structures, right? Hamming codes. Now, you will be able to reconstruct. If one of the drives gets defective, no? Only one of them becomes defective, you will be able to reconstruct the correct value using the parity bits, okay, stored in the different parity blocks, even if the parity blocks themselves are destroyed. Do you follow? So this is fault tolerant level 1, which means that if one of the drives gets defective, it can still go on normally. Do you follow? Level 6 is double parity. It has more parity, so which means that even if two drives become defective, it can still go on normally. Do you follow? Kasi dalawa yung kanyang parity. Okay. RAID 10 is a combination, or RAID 10 is a combination of mirroring and striping. So if you have a 4 gig block, no, dalawang 4 ano, you even for 1 gig disks, eventually you will just have a 2 gig disk because okay, the blocks are mirrored and at the same time stripe. So stripe yung hard disk 1 with hard disk 2, but hard disk 1 is mirrored to hard disk 3 and hard disk 1 is mirrored to hard disk 4. Do you follow? So it has both the advantages of fault tolerance and improved performance. Do you follow? So may mga question dito, no? So you answer that question in our in our guide. Okay? Eventually hindi pa nagtayo no. Now, RAID is mostly useful in mechanical drives. Okay? How about in SSD? What's the relevance of RAID in SSD? Eh, wala na tayong disks. Do you follow? In SSDs, we don't have disks. So RAID 0 is irrelevant. There's no performance in RAID 0 if you use RAID 0 with an SSD. Okay? Do you follow? But RAID 1 is still relevant in SSD. Why? Because of fault tolerance. You can mirror 2 SSDs together. That's done nowadays, no? By the way, in RAM, that's also done, no? Now, you can mirror 2 SSDs together so that if one of them gets destroyed, normal operation still goes on. Okay? RAID 1.0 is also useful there, no? And then RAID 5 and 6 parity bit is will also apply. So basically, what doesn't apply in SSD is RAID 0 because obviously there's no significant performance in terms of improvement in terms of performance. Okay. Okay, so you can answer the questions there. No? Any questions so far? The exam will open at 4 o'clock, or rather 8 o'clock on March 14. Okay, so that I can submit your grades on the 3rd week. Okay, so wala na tayong klase, no? So next week, this will be your review week. We will not meet anymore on the 2nd week of March.
Oh, sir, may clarify lang po ako, sir. Ang ginamin mo po, sir, like 14 to 18 mag-exam yan na like take home.
Yes, take home.
Sige. Salamat, sir.
You can take your time, okay? Para di magdugo.
Sige po.
Ha?
Thank you po. Yes po.
You don't have to hurry up, okay? Take time. Siguro mga 8 questions. Okay?
Sige po.
And I think I can give you 2 tries, okay? 2 or 3 tries. I'll figure out.
Ay, dili day siya PDF day, sir. Murag kon sa siya.
Question lang para automatic. Ha?
Sige.
And you can of course upload. You can upload your solution, okay? I'll give you a slot to upload your solution, okay? In Excel. Any other question? Everyone, so good luck, no? Everyone? Questions? So you have checked the attendance. Can you kindly check? Tama ba? Ang Arellano? Atiansar? Is Bation here?
Present, sir. Present, sir.
Bation. Wala na si Bation, okay? And then we have Dabon, De Jesus. Duguran?
Yes, sir.
Present.
Wala na pa. Paubos na aking 40 minutes na. Okay. Okay. Espera is not here. Bye, everyone.
Bye, sir.
Thank
Thank
you,
you.
sir. Ayo, sir.
Thank you, sir.
Okay.
Thank you po. Thank you po.